Hi, let's continue with a discussion on the mathematical interpretation of the word of in the phrase A over B of C over D. So in a previous video, we discussed an example of this type, 2/3 of 7, where notice this number is not a multiple of 3. By definition, we said 2/3 of 7 is the length of two parts when the segment from 0 to 7 is partitioned into 3 equal parts. Today I would like to discuss this example, 2/3 of 7/5. So the only difference between these two examples is here we have 7 and here we have 7 in the numerator, but this is a fraction, 7 over 5. So the definition remains very similar. 2/3 of 7/5 is the length of two parts when the segment from 0 to 7/5 is partitioned into 3 equal parts. And in fact, in general, we can define for a fraction A over B and another fraction C over D, we can define A over B of C over D in exactly the same manner. So let's look at the definition and then we will look at this example and see how to compute it. So A over B of C over D is the length of A parts when the segment from 0 to C over D is partitioned into B equal parts. Now let's go ahead and discuss 2/3 of 7/5 on the other board. So today I would like to discuss this problem, 2/3 of 7/5, a fraction of a fraction. The reasoning for this is very similar to 2/3 of 7, which we discussed in another video. So let's quickly review how to compute 2/3 of 7. In another video we said 2/3 of 7 equals 2/3 of 7 over 1. We rewrite 7 as 7 over 1. And in the next step we say using FFEF we can multiply the numerator and the denominator by 3, which is what I have done here. And then we said we look at this fraction 3 times 7 over 3 times 1 and we think of it as 3 copies of 7 over 3 times 1. Then what we have here is 2/3 of 3 copies of 7 over 3 times 1. And in that video we said if this expression is hard for us to keep in our memory, we can just think of this as 2/3 of 3 copies of something. That something could be an apple, could be an expression, but let's focus our attention on 2/3 of 3, because whatever that is, then 2/3 of 3 copies of this thing is what we have here. So, and by now 2/3 of 3 very clearly is 2. So 2 copies of 7 over 3 plus 3 times 1. And once again we look at this as expression and we say that's really this fraction 2 times 7 over 3 times 1. Another way of saying 2 times 7 over 3 times 1 is really 2 copies of 7 over 3 times 1. And now once you have this expression, it's very easy to calculate that this fraction is 14 over 3. So 2/3 of 7 is 14 over 3. And in the last video we commented about this expression. Look at this expression. This is a fraction, and in the numerator we have 2 times 7, product of 2 and 7. 3 times 1, product of this 3 and 1. So keep that in mind, because that's pretty much what I'm going to say for this example. 2/3 of 7/5. This expression is similar to this line. So every line will match up with the reasoning of out here. So now what we do is we look at 7. 7 is not a multiple of 3. Using FFEF, we replace this fraction by this. We multiply the numerator and denominator by 3. So in this step I have 2/3 of, instead of 7 over 5, I replaced it by the equivalent fraction 3 times 7 over 3 times 5. And now once again I view this fraction as 3 copies of 7 over 3 times 5. So this 3 is this 3. And so I have 2/3 of 3 copies of something. Once again, you can think of this something as an apple, and so you have 2/3 of 3 copies of that apple, that expression. So that this way, by thinking of this as an apple, you can simply focus your attention on 2/3 of 3 calculation, which you know is T, 2. So now we have 2 copies of that thing, 7 over 3 times 5. And what is another name for 2 copies of 7 over 3 times 5? It is simply 2 times 7 over 3 times 5, which you can calculate to be 14 over 15. So 2/3 of 7 over 5, but this reasoning is this fraction. Look at this fraction. In the numerator, you have 2 times 7. 2 times 7. So in the denominator, we have 3 times 5. 3 times 5. And so I hope you're getting an idea of how to calculate A over B of C over D. Let's summarize this reasoning using letters in the next video. Thank you.